Hi, and welcome to this module on the science of composting. Composting is a common term that all of us have heard or read, and it is not at all a new practice, as some of you might think. Did you know that there is evidence that Romans knew about compost? Or that George Washington used to produce and promote it? Being such an old practice, it probably has something of interest. But do you actually know what composting is? Is it true that we get a fertilizer, or does it always smell bad? In this module you will learn those and more aspects. Composting is a controlled decomposition of raw organic material into biologically stable humic substances, also called compost. This is carried out by microorganisms in the presence of oxygen. The final product, compost, is stable, doesn't degrade further, and it can act as an excellent soil amendment. Let's now have a closer look to what exactly happens during composting. The first ingredient we need is raw organic material, such as food waste, jar waste, manure, agricultural waste, municipal organic waste, etc. These materials are broken down into smaller particles and are later piled up. This breakdown can be natural or controlled. When natural, first the compost pile is made and then the breakdown happens, which is carried out by earthworms, nematodes, and soil insects such as mites, sawbugs, springtails, ants, and beetles. When controlled, first operators break down large particles through grinding, shredding, or chopping, as shown in the video, and then they prepare the pile. Breakdown in this case is a preliminary step. Of course, the controlled breakdown is much faster than the natural breakdown. Once optimal physical conditions are established, microorganisms naturally found in soils colonize the organic material and initiate the decomposition process. Soil bacteria, fungi, actinomycetes, and protozoa are the most commonly found microorganisms. The decomposition process can be divided into two phases, the active and the curing phase. During the active phase, temperature increases rapidly due to the metabolism of microorganisms. In 24 and 72 hours, temperature can rise up to 55 to 70 degrees Celsius. This temperature increase hygienizes the material by killing pathogens. It also contributes to eliminate weed seeds, and it breaks down phytotoxic compounds. Under these conditions, thermophiles, those microorganisms that function at temperatures higher than 41 degrees Celsius, take over the decomposition activity. The active phase normally goes on for several weeks. During this time, oxygen and water need to be replenished in order to ensure the activity of the microorganisms. Once all the easily degradable or digestible materials are eaten, the activity of the thermophiles will drop, and the curing phase starts. This is characterized by a temperature drop to 37 degrees Celsius. Oxygen consumption also drops, and mesophilic bacteria recolonize the pile. The decomposition of organic materials continues into stable humic substances. There is no clearly defined time for curing. It can take as long as 1 month to 1 year, depending on feedstocks, composting method used, and management. How do we know when compost is finished? Compost is considered finished when the raw feedstocks are no longer actively decomposing and are biologically and chemically stable. The parameters that are used for this purpose are maturity and stability. Maturity is usually defined as the degree of humification, conversion of organic compounds to humic substances, which are most resistant to microbial breakdown. Stability, on the other hand, is indicated by temperature and oxygen consumption. Measuring compost stability is normally easier than measuring maturity. The most clear indication of a stable or finished compost pile is when the temperature at the center of the pile returns to near ambient and when the oxygen concentrations in the air cavities inside the pile remain greater than 10% for several days. Once the curing phase is over, depending on the final use of compost and the origin of the organic material, the operators might want to separate possible impurities such as plastics or metals, or oversized and not fully composted chunks of organic waste, wood for instance. This is done by sieving the matured compost. Sieving or screening usually takes place before or after the curing phase. It is used for two purposes: to separate impurities and to produce a range of product grades suitable for various end uses such as soil conditioning, mulching, or others. Often, the organic oversize is fed back into the processing system so that they break down fully. There are engine-driven sieves as well as more simple and low-tech sieves. As long as they accomplish their goal of diverting impurities and separating the compost into different particle sizes, all of them are valid. In each location, one or the other should be chosen based on the local capacities and needs. So after sieving, we should have our final product. Are you guys aware of what happened here? We started with something like this, which is raw organic material, in this case from my kitchen, and we ended up with a good-looking, fresh, and very well-smelling compost, ready to be applied in anybody's garden or field. But actually, what is the added value of adding this compost to your soils or to your fields? Let's have a look to that. Compost has many advantages. Here we will mention 5. On the first hand, it represents an organic matter source, which improves the chemical, physical, and biological characteristics of soils. Then it also contributes to water retention. It promotes soil structure by increasing the stability of soil aggregates. It increases soil fertility and cation exchange capacity. And although it contains nutrients, its value does not rely on its fertilizer capacity or fertilizing capacity. However, it can reduce fertilizer requirements up to 50%. Let's quickly refresh what we learned on this module. In this module, we learned first about the composting process, including the active and the passive phase and their distinct process characteristics. Secondly, we also learned about maturity and stability as 2 process parameters that we can use to determine when compost is finished. And finally, we mentioned some of the interesting benefits of using compost in our gardens.